investigator in Hillsborough County in New Hampshire. He's been our mentor and our guiding force to bring this Airblast sprayer calibration project to Pennsylvania. 2 years ago we did a really heavy-duty job during winter meetings to do boom sprayer calibration, and we found out there were a lot of issues with boom sprayers that really needed to be addressed. And then we got to thinking, well, that's really easy because you can put the cups under the nozzles and collect it, but what do you do with an Airblast sprayer, because it's kind of difficult to do that. And lo and behold, that September we went to, yeah, that's not really very effective. We went to New Hampshire for a professional development workshop, and George was there with John Clements from University of Massachusetts and doing this demonstration. I said, so that's how you do Airblast sprayer calibration. And being my personality, I'm like a kid with Christmas. I'm like, oh, I gotta have one of those. And everyone convinced me we needed to wait and see if it would be something our growers would be interested in. And good fortune or bad fortune, I remember George Hamilton's name because my counterpart in New Jersey is George Hamilton, and I'm very glad I did because he has brought this to Pennsylvania. Last year as a field demonstration and some initial calibrations out in western Pennsylvania, and it has come on like wildfire, and every grower that we've calibrated our sprayers has, even the ones that have just been a little bit of a change, made a significant difference. And that one that the ones that need a little bit of a change were maybe 2 out of all of the ones that we did. Most of them were really kind of eye-opening, let's just go with it. So I'm going to turn it over to George, and he's going to talk about some of the things that are, and the importance of calibration, and show you what we're doing here with this.
Well, I'm originally from Pennsylvania, so it's like keeps coming home. But this, out of how many years? 40 years of the Ag Progress, and this is the first time I've ever been here, so it's kind of déjà vu here. I remember working just over the hill, Rob, in the apple orchard, looking at your smudge pots. They had an underground system for smudge pots, and I was the one who said that calcium reacted with aluminum, causing pitting, causing them to leak. Boy, we have a mess of oil on the ground. Well, we're going to talk about sprayer calibration. And with sprayer calibration, I usually look at the audience and say, what is calibration? What does it really mean to you to have something calibrated? And here we're looking at an Airblast sprayer. Anybody? What do you... Lawn service, what do you say when you say something calibrated? Proper amount on evenly. All right, if I'm doing the ground, evenly is kind of important. But if I'm doing a tree, how do, even becomes a harder, because we're dealing more with a three-dimensional object. And that's what causes to calibrate a sprayer, an Airblast sprayer, more difficult than a boom sprayer. Because the boom sprayer, it's 2 dimensions. It's down and out. Right?
But isn't that why it's even more important, George?
Well, yeah, it really is. So, when I'm looking at calibration, I'm looking at what is the output out of the machine, and is it getting to our target? And, most growers, if we would have had a lot of orchards, they would say, okay, calibrating is knowing I'm putting 40 gallons per acre or 60 gallons per acre per this orchard. And my first question to them is, how do you know if you're doing it? Well, 300 gallon sprayer, I'm doing 5 acres, that's 60 gallons. I said, well, is your right the same as your left? The right side of the manifold the same as the left? And they, as I'm getting these blank looks, that's what the growers do to me. All right, I had a situation down in up in New Hampshire, Mason, where a person bought an orchard, around 17 acres, had no knowledge. The previous owner said, spray the big trees on the right, little trees on the left. Well, he cut down a couple big tree rows, so all of a sudden he's spraying the little trees on the opposite side and the big trees on the other side. Well, we had a rainy year. He had major scab. The next year was dry, the next year was rainy. Then he calls me in. George, what's going on? I took a spray schedule, went through right materials, right time, right amounts. So we were starting this project, so we went out and calibrated a sprayer. The one side was 40 gallons, the left side was 80 gallons. That averages out to be 60 gallons. The right side was for the big trees, the light side was for the little trees. It made sense. The grower here, this orchardist, had been there for how many years, and he never knew the difference between one side versus the other side. I called down to the company that sold, or that originally sold the sprayer to the original owner, and they said, well, he calibrated so the big trees were on the right and the little trees were on the left, so he always would only spray out of one side. We recalibrated it to 60 gallons on both sides, so now he's spraying 60 gallons on both sides. We are turning on and off nozzles according to the size of the tree, changing gears to get the right output. So I'm looking at both the output, I'm looking at speed. All right, the speed, you cannot go by what's posted on the tractor. With speed, I always mark out, in this 50 feet, I usually do 200 feet within the orchard or within the structure that we're doing it. And if there's any hills and valleys, I try to go down the hills and valleys. Down at Biglerville, we did one of the dupes, you know, top the hill to the other top of the hill, and we time it both ways. And I usually look to make sure it's within 1 or 2 seconds. We start going more than that, I make them do it again. I always do it half a tank. Okay? Half the time it's going to be more than that, half the time less than that. Okay, so half a tank is the average. When I have a full tank, I'm going uphill, it's going to go slower. But if I have less than that, it's going to go faster. So that's why doing it on an average. So that way we take out some of the variables. I also, when I'm here, I'm a teacher, so I always put in other facts here, is if you're working with growers, and those growers here, always change your start place when you start to spray. Because row number 1 is the first row as you come out of the barn or spraying up the scent. Don't make it row number 1 all the time, because you're always going to end at the same place. So if you start spitting out at the end, I'm going to guarantee you you're probably going to have more problems where it's going to run out if you always run out the same place. So okay, you start on, you know, row 1 here, I go over in the middle, start in the middle, and do it backwards. So I'm not always running out at the same place. Change that starting point from spray to spray, helps you to get better control over, okay? So that's, you know, one little trick to me. So we got our speed, we measured this unit, we already went through it, and the sheet that you have is a blank form. And I have growers fill this out. The biggest thing with any type of sprayer calibration, from broom sprayer throughout, people don't write it down. And I've had 2 mishaps where a farmer died of a heart attack, 3rd week in March, right at the critical time starting of spraying 100 acres of orchard. Nobody else had it because Donnie had it all up here, and Donnie's gone. We spent a day calibrating the sprayer to get him through that first season. You know, I had another situation, not with an Airblast, but with a boom sprayer. Dairy farmer had a condition, he was in a coma, and the corn had to be sprayed. What do we do? You know, boys didn't even know which tractor Dad used to spray with. So we went out and calibrated. They called me up, I said, okay, we'll be right out, and we were able to take care of it. But if they had it written down, they had a starting point. I have one orchard that has 7 different spray rigs. All right? They have this written down. There's 8 different people that can spray on that farm. How do you keep which tractor to what sprayer goes at what gear, at what pressure? By having it written down, they go to the office, they pull it out. Okay, I'm driving, you know, the Ford 2120 with the Friday Air Cadet sprayer. So it's right there. Okay, and you notice I tell what gear, what's the tank capacity, what is the RPM to the tractor, what is the pressure that you're running at. So it is written down, so you got a starting point. All right? So first thing is how far? Well, we went 200 feet and we measured it up and back. It was like 46 seconds even going up and 46.2 coming back. That's within a second. That comes out to be 2.96 blank, 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 roughly 3 miles per hour. I think the tractor listed it at 3.2. Right off the bat, we got, what, an 8% air? Okay.
And the bunch, Bob, that you calibrated in Bedford, they found out by doing that they could use a different tractor speed and increase their efficiency. So it isn't just calibrating the sprayer and the outputs, those things that George is talking about. That grower had 6 sprayers, and they could not only improve their efficiency times 1, it was times 6.
Well, usually 20% to 30% of the time, the speed is wrong. The ones I've done, all right, both fast and slow. Remember, as the tires wear down, you're not going as fast as you think you are. You know, and I have literally orchardists that go 5 miles that way, 6 miles that way, and 7 miles that way, and you start to think how much time they're on the road going back and forth, filling up. They only have one place that they fill up is back at the home farm, and they're on the road. How much are they wearing down the tires? I think every year they're buying new tires for a couple of those tractors. So that brings me to another point, sideline. You change tires on the tractor, recalibrate. That's a major change. Okay, so we got our speed. Now, one of the things we do in the orchard, because we're doing this in the orchard, is we measure the distance between rows. And I don't do from row 1 to row 2. I go like from row 1 to row 5, and I average it. Because what happens if row 1 to row 2, that's where a stone was, and they pushed it out 2 extra feet. If I do 5 rows, I get a good average of, geez, it's supposed to be 12 feet. It was 5 rows, it was 60 feet. But if I measured 1, it was 14 feet. Right there, how much of an error. Okay, so do more than 1 row to get a good average. That is important so that we can calculate how many feet is there in an acre. So if I start driving and I go, and if it's 12 foot, I would have to go 3,630 feet, and I would do 1 acre on 12 foot. So 12 foot by 3,630 feet, that's 1 acre. Okay? So that's going to be important when I calculate how many gallons per minute this is going to come out. So that's the front side. Okay? On the back side is we now look at the nozzles. So each one of these nozzles, okay, we have a whirl plate and a disc. We go through and write down, and if you notice, in the black, or in the very top, it says, determine left versus right. Look at the sprayer from behind. So I'm telling you, we're looking from behind, not from the driver's seat back, because it's always, which is left, which is right. The chicken or the egg. So I'm telling you, from behind, left, right. I'm also telling you is the left side, I start with 1 on the bottom and I go up. Usually growers are, many times it's listed the opposite way, but I found growers turn off the top ones more often today than they do the bottom ones. And down here in Pennsylvania, I've been preaching they need to keep these bottom ones open now, because we got a thing called brown marmorated stink bug, and we better keep it down here. If it comes up to New Hampshire, I'm retiring quick. Okay. We do have a few in Portsmouth, but we don't have them in any of our orchards. Leave the nozzles on the bottom so that when you're spraying, you're directing it to the base of the tree, because some of those stink bugs are going to be down low in those weeds underneath the tree, so more chances of keeping them under control versus them migrating upwards. So I like to keep the little thing I came up with, been telling growers as I've been going through. Before we turn on the sprayer, we go down through and we write down what is the tip size, what is the core. T-jet, they're numbered. This system, they are not numbered, they're colored. So the tip size, they were all D2s. The core, the whirl plate underneath it, was different colors from brown to yellow. And right here is a whirl plate, a stainless instead of ceramic. And right there is what your ceramic whirl plate is also. Then,
if they're brand new, George, it's important to calibrate again.
okay. Man, this sucker's big.
Yeah.
What is it?
I don't know what side. This one's, these two in here are 8.
These are 8. Okay. So this is what the tip looks like. That's a huge one. I'd be using this actually on sweet corn, around nozzle 4 or 5, to get into the plant. For orchards, don't use this size usually unless we're really going with a dilute spray, 200-300 gallons per acre. We'd be using this and going slow. Okay, so
they're not always exact and correct from the manufacturer.
all right, we've had one case where I literally opened up the plastic. It was sealed, put it on, and it was worse than the old one. And so we all kind of went like this, and so we took the one off the other side, put it on. It was right in. It was mismarked. Only had that with 40 sprayers twice.
And we had one. We took one out, replaced a new one, and it wasn't right, and we had to get another one. And then it wasn't right.
So when you replace a nozzle, I will always recalculate. You know, that's really important. When you start to change, any nozzles, change speed, change your tires, that's major changes within the calibration. So now what we do is we know what all the different nozzles are. We now go through and collect what's coming out. All right, before Carrie met me for the first 12, we had tubes that we would put over the nozzle, clamp on into the bucket. Now, I have 3 different sizes of tubes, all right, and I'll tell you right now, the rears sprayer, it isn't a perfect round. It's round with 2 tags on the side. How do I get those tags in here and also keep it tight? All right, it caused a lot of problems to me. So you would do it into 5-gallon buckets, and then we would have, when we were done, we'd pour it into our 1-gallon container. If I had 3 gallons, you know how many times it took. And we had, 8, 9 per side. Don't forget, most farmers have the flip, so we would have to do twice on the right, twice on the left. Gee, some of them weren't right, so you had to do it over again. Spent half a day calibrating just one sprayer with this method. So John Clements got a special EPA grant, and John was able to buy a unit like this. This is from Belgium. It's a calibration unit device, AAMS, Advanced Agriculture Measurement Systems. And over in Europe, many of the countries require the orchardist, the farmer, to have their sprayer inspected every year or every 2 years. So if I'm the orchardist, I would go to a real nice fancy place in town. They would have this type of unit or some type of unit, and they would check the calibration, the speed, and the output. Right? We don't have anything like that. Now, if you're Global Gap certified, one of the requirements is to have an official calibration. Well, in this country, where do we get an official calibration? So that's how the two farms that Carrie and Bob went and did, was to make sure they were certified, and they accepted the form as being an official calibration, since it came from the university and university people were doing it. So they were able to help those farmers get through their food safety inspection plan by having come in and calibrate.
But not only that, both of those farmers said that at a minimum, they had, because of what they learned, they were going to increase their efficiency, but also decrease their expected costs of their spraying 10%.
Okay, the reason I like it is this here. This hooks on to the nozzle real quick on the side of the cap. You then tighten it down, spins around, and tightens right on the nozzle with the spray. So then the fluid would go up through the housing and run out. And in this, right now the way it is, the water would miss the cylinder. For us to collect, pull this pin out, push it back, and for the given number of seconds, if it is a real small diameter, we go for a full minute. The larger the diameter, we'll do it for 30 seconds, or that big one that I showed you, 15 seconds. Then I would just multiply by 4 if I did 15, 3 if I did 60, 2 if I did it for 30 seconds, or 60 seconds is a full minute. So I know what the output is. Doing it this method, all right, I now know what every single nozzle is putting out. Now, we're operating the tractor at the RPMs that they normally spray. We're operating at PTO, okay, RPMs. We're also operating at the pressure that they stated. So it's just like the field, okay? And I have every single one. So the grower tells me, in this block, not using the top two, I already have those numbers, I just subtract them from the total. Or I'm not using the bottom two, I can subtract from the total. I don't have to do it over again, because I got every nozzle. If it's a flip over nozzle, we do both sides. Many growers have concentrate and dilute. This one, 50 gallons and 100 gallons was their goal. We'll talk about what this comes out in a second. If I'm really lucky, and I should also say there's only 6 of these units in the United States, so 2/3 of them are right here in front of you. Cornell has one, University of Mass has one, 2 out in California, New Hampshire, and Pennsylvania. All right, and literally this speeds it up, so instead of spending a full day, 2 hours or less, you know. And if I'm doing multiple calculations, it really, because you get a flow to it. The first one takes longer, and after that you can wrap them off or get them done, especially, you know, with the flip overs. If the grower does what they need to do prior to going on the farm, and I think you got that, there's a checklist of items that they need to do, it speeds the process up. It actually cuts the time down in half, if not more. Okay? Because we had a couple growers that didn't do it, and we spent 4 hours just trying to get it calibrated.
To get one sprayer done.
Yep.
Because we spent more time fixing the sprayer than we did calibrating. Right?
So we hooked these up, okay, and I ran this for 30 seconds. And this is the output on both sides. Again, the left side, the right side. Number 1 is on the outside, number 1 is on the other outside. Now, they have it so that the first 3 nozzles are all the same. The next 4 are the same. So they have a pattern that is quite similar. And if I add this up for a minute, the left side is putting out 3.21 gallons per minute. The right side is putting out 3.39. That's plus or minus 10% from each side. I'm happy. So this is not bad. This is actually pretty close. I've seen many a lot wider range, and Bob, you've seen a lot worse than this. If it gets more than a 5%, now 5% high, 5% low, that's a 10% range. People usually think, well, you take that and take 10%, and that's a 20% range. Okay, so there's a difference there. So this side is 3.1, almost 4. Okay, so I add this up. This is putting out 6.6 gallons per minute. Okay, and then with 6.6 gallons, what we do is we figure out how many minutes does it take running at 3 mile or 2.96 miles per hour to do an acre. Okay, it takes 13 3/4 minutes. So if I know what the output is for 1 minute, I multiply it out, it comes out to be 90.75 gallons per minute, per acre. And they were looking for 100 gallons. All right? He is going a lot faster than he originally thought he was going. And that 0.4 of a mile makes that kind of difference.
Almost 10%.
Okay?
Before we forget, you had mentioned that method you used before with the hose and the clamps and all of that, but truly, what do most growers do?
Most growers took a full tank of gas and sprayed, and then filled it back up and saw how many gallons and said that's how many gallons they're putting out. They never knew what the right side versus the left side. 20-30% of the sprayers are going to be more in the 5% plus or minus range.
But the one sprayer we saw not only was the right and the left side, but because he had a sprayer that had diaphragms on it and they were cracked and leaking, it wasn't even going out one side or the other, it was going up in the air.
Okay, I had a grower the other grower that got me into doing this on farms was almost a brand new Duran Whalen sprayer, stainless tank. The hose that came back underneath the sprayer got stabbed and there was a hole. She was dumping probably 20 gallons an acre or 40 gallons right on the ground. She never knew it. She was by herself. Her daughter worked in the greenhouse. She did all the orchard, around 20 acres of orchard. Nobody ever followed her. She didn't notice. She had turned the sprayer off going around the corner. It would turn off the hose so it wasn't leaking when she went around the corner. It just leaked going down the row, and that's behind her. She's going forward. All right? Why did I have scab? She had every spray on time. She wasn't getting the volume in the tree. It was going on the ground. It happened. I had another grower that changed the angle, all right, of the plumbing. It was a 45, you put a 90, decreased the flow rate, all right, and this one side was putting out around 15% less than the other side because they changed the way it was put together, not realizing that one little change will make a difference. So those little things. The other thing that happens is first time in the season, if you didn't flush this out, we tell you to flush it out well, open up nozzles, clean it out. There's going to be rust. So all of a sudden, we see this one, I think, was down here. Am I right?
One that was here.
Okay.
And then and that was because the roll plate was cracked.
Okay.
And it was leaking out faster than it was going in here.
All right. But we had one that was clogged.
Yes.
All right. And what do? The farmer takes it out, Okay, it's got a clog. Geez, I don't have anything. What do? How am I going to get that cleaned up? What are they doing to themselves? Pesticide safety. All right.
I thought you said they had a wire. They always have a wire.
Okay, hold on. Can of air. In there. You can put that up in the housing, clean it out. It's amazing how fast that does. This is my dad's trick. All right, now the wire. What are you going to do? Ceramic. How fragile is it? You put a piece of wire in. Geez, I'm going to do it harder. What did you just do to that hole? You cracked it. Chipped it. So instead of 2 gallons per minute, now it's going 2.5, 3 gallons. All right. The other one, what I tell is, if you're going to use anything, wooden toothpick. All right. Less chance of breaking, especially any of the metals. You still have the chance to crack it, as Eric did when we were doing one.
I helped.
And you helped. I wasn't going to say it.
That's
you
okay.
volunteered. All right, but you still use this. Don't use wire because there's more chance of breaking them. Dental picks. I think everybody was saying, oh, we'll just use dental pick. What they didn't read, it was a rubber tipped dental pick, not the stainless steel or tungsten. All right? Rubber gives, it's not going to break. So I tell people to get these. So the other thing I want to mention when I'm going down through is the other area that I see a lot of problems is pressure gauges. All right, this is a 600-pound pressure gauge. The accuracy of the pressure gauge is going to be 1/2. Once we go more than 50% on either side, the accuracy drops drastically. So if I'm running this, sprayer 200 to 400 pounds pressure, this grade gauge is fine. But if I'm running this this sprayer at 100 pounds pressure, this is way over and the accuracy is going to be dropping. It's not going to be as accurate. If I'm going to be running 100 pounds, then I'm going to run a 200-pound gauge or 300-pound gauge. I prefer the extra $5, $10, $12 for an oil pack because the accuracy is going to be better versus dry. All right? They're not that expensive. All right, now if I'm running this sprayer at 50 pounds, then I have a 100-pound pressure gauge. This is the one that usually I recommend for weed sprayers because they're operating 40 pounds, my growers, or your boom sprayers. So 100-pound one's okay. 80-pound would be better. I'm at 40, but you can see the accuracy is within 40 to 60. It's going to be more accurate. So that's a little trick with pressure gauges a lot of people don't hear or know about. So have the right pressure gauge. Oil pack is better. All right, so we do the math. We know what the output is. The problem buying a European design piece of equipment is it's in metric. All right, even though we were supposed to be metric back in '68, it still hasn't happened. So I take this, I get it out to be a per minute, and I convert it into gallons. So we went down through that, all through there, so we know what it is. Now, I talk to the grower at this point. You operated, what is your goal? Can you live at 91 gallons per acre? Then if I'm spraying 2 acres, you're going to be using 182 gallons. But if you're dead set, okay, I got to have 100 gallons because Rob is telling me it's got to be 100 gallons. Okay, what are we going to do? First thing I'm going to say is, okay, let's try going slower and gear down. What does that do? All right. If that doesn't, then we got to say, geez, that took us too far. So now what do we do? I don't like to monkey around with pressure. I like to see a grower operate the same pressure regardless of whatever block because it gets harder to adjust it. You understand what I'm saying? I like to keep the same pressure. I change speed. Well, what happens if, geez, George, these trees are real tall and I'm only using 1 through 6. maybe I should be opening up 7 to get the tops of the trees, especially mid-season on. All right, I want to make sure I get the coverage. So those darn brown marmorated stink bugs up the top tree, I'm going to get them. Okay, you don't have them here. Good. Okay, so, you know, we open up another nozzle, that's going to increase our output. So there's several different ways. If that doesn't do it, maybe I want to change nozzle number 5 or 6 because that's the thickest portion of the tree and I want more material going out into that. You know, there's 2 philosophies on sprayers. One philosophy is wherever the thickest part of the tree is, we want to put out more output at that. The other philosophy is I want the same amount throughout the whole boom. Now if I'm doing a tower sprayer, yes. So I have uniform going out through that tree. But we got something that's up 10, 12 foot tall with a 12-foot tree, right? Here we got an arcing pattern and I want to put out the thickest portion of the tree the most. Remember, as the sprayer, another thing that isn't in a lot of the books is as this blade spins counterclockwise, this tends to take the spray coming out and move it upward more. So we may need to take these nozzles and point them down flatter. So it's going to be at the same place. Where as this goes around, what does it do on the opposite side? It tends to knock it down, so we may need to turn these up because of the way that the sprayer, they all go counterclockwise. How many people have heard that before? Okay, only 2 of you. All right. So that's the refinement. Now, what Carrie is doing is a little trick that I do. Instead of going out and buying a $13,000 patinator, I take this and put it in my tree, and if I have real tall trees, I take another one and put it on top, and this is water-sensitive paper. So I have this on the outside of the tree or in the middle of the tree, pass through towards the sprayer. So the tree's out here, got inside, outside, and I can see the pattern. And they have a real nice little book that shows you what the pattern should look like. And we did this down at Dawson's Farms and her eyes were this big. She thought she was doing a fantastic job on her peaches and she was doing a terrible job on the peaches, but the apples, because it was more of an A-frame, narrow at the bottom to a peak, she was doing a great job getting penetration. She was wondering why she had breakdown. Right there. I showed her. She had no coverage.
When we were talking about alternate rows and that type of thing, issues, and some of the SIs that are having problems with some of the types of chemicals because they're not getting in as far to the trees as they come.
Oh, what is happening is farmers try to cheat as much as they can. I shouldn't say, don't quote me in that in the newspaper, I'll shoot you. We try to be frugal with our pesticide dollars, and they are not putting it at the rate is on the label. If it, with these SIs and the strobies, if it says 5 to 8 ounces, you're doing 5 to 8 ounces. You're not doing 4 because you're not putting at the full rate. You can develop resistance faster. Some of them we know 20 times of using a product, we use the efficiency, or we could develop a resistance. Some materials, instead of 20, we know it's 40 applications. And a lot of the SIs, we're up in the 30s and 40s probably down here, so the resistance could be right there on the cusp, that we could see it. So if I'm putting a lower dose, I'm causing that resistance to develop faster because it's not at full strength that will kill the organism. Make sense to you? So it isn't like, and we're so used to the Captan and Imidan, or Captan and EBDCs, Manzate, Dithate, those type of materials, that yes, we could reduce them and still good because they were multiple site reactors so that the resistance would not develop. So we have to be in a different mindset. And this really shocks people when we use this type of device. You know, now they got real fancy ones with cups that go up 20 feet up in the air, and they run on a rail, and they go back and forth 10 times, and you can see what the pattern is on the tree.
They cost $13,000.
All right, so $1 per piece of paper, clothespin, 2 pieces of wood. You know, give me the $13,000, and I'll spend $100 on making this. All right, and I have 3 of them that I put together. So that's. Did I miss anything?
I think the one thing that you talked about saving 10%, and it doesn't sound like a lot, but when George was saying that some of these growers do 40 sprays a season, that's a lot. Every time it's 10%.
Now I got to do it. Since it's being recorded, I got to define what I mean by that. Everybody thinks insects and disease, fungicides and insecticides, right? All right. How many thinning sprays are you putting on? All right. Do they have insecticide in some of those? Sometimes. Many times, no. How many growth promoters do we put on? 2? Okay, inhibitors. How about stock drops? We're putting 2, maybe 3 on. All right, we forget that. Now, how many nutrient sprays are we putting on?
None.
None?
Smart.
Okay, a lot of my growers are putting on maybe 5 calcium sprays and 2.
Oh, calcium, I forgot.
Okay. See, Hamilton came through here. All right, and probably 2.
Nitrogen and all that.
No nitrogen, but usually minor nutrients. We're putting on boron at bloom to increase pollination, hopefully, and we might be putting on minors. So if we start adding up those sprays to our insecticide and fungicide, all of a sudden the number of spray events increases, and instead of looking at $1,500, $2,000 an acre, we're now up to $3,000, $4,000 an acre. All right, we replaced all the nozzles on one sprayer and a new pressure gauge with T-Jet, the whirl plates and the tips. It was $160. Okay, now if apples are selling for let's say $20 a bushel, you're telling me you can't afford 8 bushels of apples to replace them? And I think apples are going to be $40 a bushel this year. All right, and you're putting through, a 50-acre orchard is putting through how many thousands of dollars of materials? I'm not saying pesticides, but materials. How can you not calibrate your sprayer for such a small investment? All right, don't be penny wise and pound foolish. All right.
One thing you leave it out, George, though, is that you've got different sized trees. You need different volumes.
Okay.
So you need to go through and also do tree row volume.
I would say yes, but the problem I am having now, Robert, with the tree row volume is the manufacturers of the pesticides are now coming out and requiring, especially with the strobilus and SI, so many ounces or so many rate per acre, and that's eliminating the tree row volume formulas. And that's what's hurting to me, is making it complicated for the grower to understand. So I agree with you 100%, but reality, how do we, as professionals here, we have to come up with volume is 150, 5x is 30 gallons. But the next block, 5x, might be 80 gallons. Old big standard trees. So I've gone over. I hope it's been worth your time.
And the thing too to keep in mind, and the one thing that we try and stress to growers, again, 10% may not seem like a lot, and I didn't want to ask the one grower who said that to us, well, what is that, how much do you spend on your spray bill, because that's none of my business. So I said, well, So I thought, well, what do you estimate you'll save? And he's like, over $6,000. And it doesn't take a genius to do the math to know that that means his spray bill's $60-some thousand a year. And yeah, he's a big grower. He can maybe afford 10%, but he can't. Because that $6,000 is going to be something he can invest in something else. And not only that, we did one, it was so bad, and they were doing us a favor to let us do a demonstration on their farm. Their sprayer was so bad that in order to, as a favor to them for letting us do that, but mostly as a favor to us, so we knew that we were going to get a fairly good calibration on it when we were doing it in front of 25 different teachers. We bought them all new nozzles, all new everything, including the pressure gauge. It was $160, which sounds like a lot of money, but when you realize the difference between $30 or so, plus a bushel for fresh market apples, and what for processing, Rob? Maybe 6?
No, this year is going to be.
Yeah. So there's I mean, you paid for that in 4 bushels of apples, and that's the thing that growers. It was amusing when we were down in Bedford. They're like, oh yeah, that's just some Penn State thing. You want to? I said, you know what? I got enough work to do. I don't have to come out and calibrate your sprayers. I'm still going to be busy. I don't really care. I do, but the point I was trying to make is it didn't make a difference to me as a Penn State Extension person. I was just trying to show them it was going to make a difference to them, and that was one of the growers that we did get to calculate, and he was just like, wow, you're right.